All right, we are working through the balanced forces unit, and we're still doing some introduction stuff. In the last video, you looked at common types of forces, and in this video, we're going to be going through and trying to understand one, how to draw system schemas, and how to make free body diagrams. Okay, in the last unit, in the constant velocity unit, you were going through and you were making position time, velocity time, and acceleration time graphs. In this unit, we're making system schemas and free body diagrams. And like I said in the last video, in forces, we're looking at different snapshots in time. So as we go through and look at the first assignment, one of the things that we're doing is we're going to look at how to talk about forces concerning this little hover disk. So I got this nice little disk, and it'll sit here and it just kind of floats around. It's got a little fan on the bottom, and we're going to look at different moments in time and talk about what's going on with the forces for this. Okay, and so we need to get out our little camera. We're going to take pictures. We got 4 scenarios we're looking at today. So scenario 1 is it just sitting there on the table. Ready? Take your camera out, and 3, 2, 1, snap. That's the first snapshot. The second part is going to be when it's turned on and sliding. So we're going to take a picture in 3, 2, 1. So scenario 2 is when it's turned on and sliding across the table. Scenario 3 is when it's turned off and sliding across the table. Ready? 3, 2, 1. So while it was still sliding, after I pushed it while it's still sliding, that's scenario 3. And then scenario 4, I have another one here, and this one has a rope on it. And we're going to look at scenario 4 is when the rope is getting pulled. So 3, 2, 1. Right when the rope becomes snug, that's the third, or right when the rope catches, that's the 4th scenario. Now what we're going to do is we're going to go through and we're going to look at what goes on with how to actually draw these. So I'm going to pull up the screen here, and I'm going to be drawing the system schema and free body diagrams at these different points in time. So for the first one, we're looking at, so to draw a system schema, you have to label every object. And once you label each object, you have to go in and draw them in there. So we had a disk, and every object I circle. I have a disk, you had Mr. Neutzel, you had the table, normally that would be for the floor, and then you had the earth. Now, you might not have saw the earth, but the earth was affecting the situation the entire time, so I always go ahead and put it in there. So these are physical objects that were in our snapshot. Okay, next up, I want to draw in some forces. So I label each object, and forces I draw as lines. So I'm going to draw a force from the earth to the disk, the earth to the table, and a line from the earth to Mr. Neutzel, because on each one of those I had a force of gravity. And then on the table, I had a normal force from the table to the disk. Let's go ahead and actually throw in the floor as well. The floor had a force of gravity, but the floor had a normal force from me to it, and a normal force from the floor to the table. Now the object that we care about, we always draw that with dotted lines around it. So I draw dotted lines around the thing I care about. Now that first picture was a picture of me, or a picture of the disk just sitting there on the table. So I haven't touched it yet. So right now that's all the stuff that we have. Now the disk is at rest, so now we have the free body diagram. So that's the system schema. And the way you make a free body diagram is you look at the object that you care about, which in this case is disk, and we make that a little dot. We shrink it down to a particle. So this is the disk, and it has two forces on it. The normal force, the table, was pushing it up, and that was from the table. So I draw an arrow. The arrow represents how strong the force is and the direction. I label what type of force it is. In this case, it was a normal force, and it was from the table. Next, I draw in the force of gravity. That was going straight down, and that was from the earth acting on the disk, and the disk was being pulled towards the earth by the force of gravity. Now, turns out that both of these forces are actually equal. The force of gravity is equal to the normal force in this situation. Okay, and so these two forces are equal, and we call this balanced. So this situation is balanced, which I'll abbreviate as BAL from now on. And it was also moving at a constant velocity. Okay, so it's a constant velocity and it was balanced. The velocity happened to be 0, but it was a constant velocity. That's the first one. And our second one, we still have the same objects. We have the disk, Mr. Neutzel. We have the earth. Now where you put these things, it doesn't matter on the system schema. And we have the table. I'm going to leave the floor out because the floor wasn't really ever interacting with the disk. The thing I care about is the disk, so I put dotted lines around it. I have a normal force from the table on the disk, because the table was holding it up. A force of gravity from the earth to both of those things, and also to the disk. And then the other question is was I pushing on the disk? Well, initially I started with a little push, but when we took our picture, I was no longer touching it. It was just floating across on its own. So there is no normal force from me when we took our snapshot. So this one, we go ahead and draw. Turns out it's going to be the exact same picture as our last one. So this one is balanced and constant velocity, and it's moving along the table without any other forces acting on it. Okay? Now we're going to look at scenario 3. This is when we turned the disk off and we pushed it across the table. So I got disk, table. If you remember from the picture, I was no longer touching it, so I won't put myself in there. We have force of gravity. We have a normal force from the table. I care about the disk. And as it was moved along the table, it had another force, friction. When it was turned off, it no longer provided the air, and so we have a little friction force acting on the table as well. So our free body diagram, we have the disk. If I say that the disk is moving to the right, then I would have friction going to the left, because friction is always opposite of motion. Normal force from the table. And force of gravity from the earth. On this one, we say it's still balanced vertically. Vertically it's balanced, but horizontally it is unbalanced. And so when it was sliding across the table, the forces were unbalanced, and it was not a constant velocity. Okay, it was unbalanced, and it was slowing down. The fourth scenario is when we have the string on it. So we need to add Mr. Neutral back in here. So I got a disk, Mr. Neutral, the rope I was using, the earth, and the table. Again, the order that you put these doesn't matter. You write down all of your objects. You draw normal forces connecting the objects that are touching, except we have a tension force from me and the rope to the disc. That was the tension force. And then we got force of gravity on everything. Object to care about is the disc. Now if I look at how many lines are going inside of this dotted line part, there are 1, 2, 3 lines going into the dotted lines. So that means I should end up with 3 forces. So I have the disc. I have a normal force from the table. I have a force of gravity from the earth. And I have a tension force from the rope. This one also was unbalanced, and it's not a constant velocity. Okay? It was either stopping or getting pulled whenever I touched the rope. It was either getting stopped or pulled. Okay? So this is an introduction to a system schema and a free body diagram. Draw all the objects, circle them, all the physical things that are in there. You draw lines connecting them to show interactions or forces. The thing that you care about has dotted lines on it. However many lines go into that dotted line area, that tells you how many forces will be in the free body diagram. So this system schema is used to set up how to draw the free body diagram. Okay? That ends this video. The last video we talked about common types of forces. The next one we'll be going into more examples of how to practice with using this stuff. All right, thank you.